So the plan for today, as I've said in a couple emails, the only thing I wanted you all to read for this week was the thing which was originally supposed to be read like 3 weeks ago. So we fell behind schedule because I'm spending more time talking about representational theory of mind and lot and all that stuff. So, but that's good. It means less material to cover. So the plan for today is for me to finish up the representational theory of mind stuff from last week, then talk a little bit about what the language of thought is. And then the class Thursday is probably just going to be me talking to the camera about the motivation for it, which means we're only going to get to the Kahneman fun stuff about System 1 and System 2 next week. And I will send a new syllabus out in the next day or so, which will have what the new updated reading list is. So basically, you're all on target. There's been really nothing new reading-wise for the past couple of weeks, so you can all just concentrate on your midterms and all that fun stuff. Secondly, I did post the paper prompts. Also, that's a fun tongue twister, post the paper prompts. But anyway, they're posted. Does anyone have any questions thus far? There's also the video in which I got up here for 59 minutes and like 58 seconds and talked about how to write papers. If you got a chance to watch it, great. If you haven't yet, I highly recommend it because paper writing is the #1 thing that affects your grade in this class, and it's useful if you've not written philosophy papers before. Any questions at this point with the paper prompts or the paper writing or anything like that? Or are we good? All right. Feel free to type in chat or ask out loud. The only thing I'm going to say also is just to highlight on the assignment. The due date is on there, but just a reminder that if you want to turn in a draft and get comments on your draft, I'm happy to do it. I think it's the Sunday before I need your draft by so that I can read it over, give you comments, and get it back to you in a timely fashion so that you can actually take my feedback into account. The prompts are very detailed. I want you to respond to the prompts, but also because they are detailed, it should give you a general idea of what I'm looking for. So between that and any questions you have answered and the prior reading, and by prior reading, I mean James Prior, Pryor, not like the ones that you've had to do already. Between all those, you should have a lot to assist, and any questions you have, even if it's something like, I'm scared, can you help? Yes, I'm here, that's what I'm here for. So that's paper stuff, and I'm not expecting you all to have looked over the prompts very closely yet, midterms and all that. But I'm happy to talk about it at any point. All right, any other business questions? Business, comments, concerns, etc. All right, nothing in the chat, nobody's speaking. Looks like we're good to go. All right, so my notes, which as I said, my allergies are terrible today, so I'm gonna be looking at them more. I wanna talk about, review some of the stuff we talked about with RTM, and then jump in a little bit more in terms of why RTM, why the representational theory of mind is actually worth talking about and why it's important and why it's not just like, okay, so what? So to start, I just said what representational theory of mind is. So RTM is the representational theory of mind. What do we mean by representational here? What is a representation? This is just review stuff, just to make sure that you're all alive and not too in midterm time. Eddie?
Essentially like something you can see, a physical thing that you could see. So let's say, for example, a storm, that's a representation in your mind.
Yeah, so a representation in your mind, but more generally speaking, what do we just mean? You've answered the next question I was going to ask, which perfectly. It's just, what do we mean generally with representation? Well, it's one thing standing for another thing. So in the case of this, in which like to represent or to have a representation of a storm is just to have something in your head that stands in for that storm. So that's what we mean by representation. So a representational theory of mind says that in your head are representations, or another way to talk about it is symbols. So there are symbols in the mind, and these symbols stand for other things. So in the same way that like the letter S is a symbol, what is this a symbol for in the real world? What does this stand for?
The letter S.
The letter S, it stands in for the letter S, but it's also, more accurately, what do letters generally, what do we use them for? Why do we write them down? Well, they stand in some complex, weird way for like Like if you know that,
Language.
pardon?
Language.
Yeah, language, and specifically with S, it's like, so what does this shape mean? Well, this shape means that it's a word that starts with, so that's why, you know, that word, how would you pronounce it? Well, you pronounce it with a S at front, or storm, etc. So that's what we mean by symbols, just something standing in for something else. So in the case of the mind, the idea is that you have these things in your head that represent things outside your head in the same way. So what is it to have a thought of, I don't know, it's Tuesday? Well, it's to have a symbol in your head that represents Tuesday. That's all it is. That's the core of the representational theory of mind. It's just when you think something in the world, there's something in your head that represents what's out there. And so in a certain sense, this is just our common sense idea that we have thoughts in here that are correspond to things out there, but it's just giving fancy labels in terms of symbols and representations and that sort of thing. And yeah, it's these symbols are going to correspond to our concepts, our models, propositions, things that are true or false. So that's, though, the general background here. Now, we said in the case of representational theory of mind, what we're trying to explain is our common sense thing like, I believe that it's sunny. So in this case, we've got, you can think of it as divided into two parts, the it's sunny bit. And where does that come from? This is going to be the symbol in your head. So that's just this is a circle. That's the symbol for it's sunny. And then what is it to believe that it's sunny? This was the second part of it. Oh, the screen is not clear. Let's make it go away. How about now? Is it coming back? Did we focus? Let's see what happens if I change the lighting.
It's better.
Okay, it is better. All right, so, all right, well, it'll be a little darker, but at least it'll be sharp. All right, perfect. So yeah, what I was saying is to believe something, you just have this content, this symbol in your head. This symbol means or has the meaning it's sunny. And then what is it to have the belief part? What did we say this was? Anyone remember? There were two parts to this. It was Fodor's really fancy term, but it's basically, it starts with a f and ends with an unctional. It's basically just for this symbol to play a certain functional relation in your head. So I believe that is just to have the symbol in your head in a believey way. Yeah, a functional relation. So I believe that it's sunny is for the circle to be in your head and for it to be in your head in a way that is a functional relation. And which functional relation? Well, the say the believey one. So again, this is not, in some ways, this is just very simple, taking our regular English sentence and turning it into a theory. Now, the core of this and why this is important is for a few different ways. Essentially, why this is actually not just like, oh, who cares, is because once we start saying this, we're beginning to give a picture of what thinking is. The idea is, in psychology, we're ultimately trying to understand how thinking works. And this is now saying what thinking is a matter of what it is to believe, it's a matter of standing in a certain relation to a certain symbol. So we have to say there are mental symbols. Don't know what those are yet, but that's something we can study. We can say we need functional relations. Okay, well, what's a functional relation? How does that work? What functional relations are there? What is the functional relation that corresponds to belief? But you can see how once you start saying that you have a representational theory of mind, you can begin to ask questions that a psychologist might like to ask, and you can begin to understand how a psychological study might be conducted. So for instance, if you want to know, like, what is it to believe something, you might start with your common everyday idea of what it is to believe. And you say, all right, somebody believes something, say that Trump's going to win the election. What exactly does that consist in? And you can begin to ask, what sorts of other thoughts are likely to come about if they have the belief that Trump is going to win the election? And you can begin to ask empirical questions about this sort of thing. So that's the background of most of what we talked about last time. Does this all sound familiar? Hopefully this sounds familiar. All right. Then there was the second part of RTM, which we didn't talk about enough last time, but this is really, once you have this idea that and this was like the very fancy thing with all the letters that I talked about last time of if you've got a propositional attitude P and representational blah, 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 blah. Basically, the complex language put in simple terms, having beliefs, desires, etc., is just standing in a certain mental relationship or mental functional relationship to a certain mental symbol. That's what it is to have a thought, have a belief, etc. The second part of RTM, which we didn't talk about as much, but is very important, what I want to spend the most of today talking about, is this second bit, which is just mental processes are causal sequences of tokenings of mental symbols. All right. This is really where the real core and why we're getting out of just like an interesting way of describing it into something that starts to be useful for us. What is a mental process? What is this a fancy word for? If you were thinking, if somebody asked you, give me an example of a mental process. Well, what is a process? Yeah, Cynthia's right, thought. What we mean by mental process here is just thinking. So this is a fancy way. Let's cross this out and use simple terms. Thinking. What do we mean by causal sequence? Well, we kind of talked about this last time. What is a causal sequence, just generally speaking? Or I guess it was a couple times ago. What is it for one thing to cause another? What does it mean to say gravity is causing this to fall? What is gravity doing?
That because of gravity, the pen fell to the ground.
Yeah, it's that the gravity is the thing that makes it fall, and if there wasn't gravity, it wouldn't have fallen. So what we're saying here is thinking are causal sequences. So just the same sort of thing of one causing another, of tokenings of mental symbols. So first off, what do we mean by mental symbol here? It's what we just talked about up here. So all we mean by mental symbol is whatever the things are that you believe, whatever the things are that give the content to your beliefs. So this is just like, an example would be something like that circle I talked about as the symbol for it's sunny or something like that. So all it is for these mental symbols, these things in your head that represent. That's what we mean by mental symbol here, just, those examples. What do we mean by a tokening? I talked about tokenings in one of the little supplemental lectures. What is it? The two phrases are tokens and types. So what is a token versus a type? Does anyone remember from that supplemental lecture? Or I can go over it again here if we don't have any takers. Token and type. What does it mean to say a type of thing? Like,
That's like a certain variety of it.
Yeah, so like, what type of thing am I? One type of thing I am is a human being. But you are also human beings. You, however, and we're not the exact same individual human beings. It's rather that we are instances that share similar properties. So the type is the grouping of things that share properties, and the tokens are the individual things that have those properties. So why do we talk in terms of tokens and types? Well, because when we're speaking, it's sometimes really unclear what we're talking about, because one of the natures of language is that we sometimes use the same phrases to talk about tokens and types. So easy case of this is if I say MacBook Pro, I'm talking about what?
Computers.
A computer. But am I talking about a particular instance of a computer? Like I have a MacBook Pro, but I only have a token of a MacBook Pro. I don't have the whole type MacBook Pro. Rather, I have one token. If you are running a MacBook Pro, you have a different token. And so if I say something like, this computer or this MacBook Pro doesn't work well, am I saying that rather this entire model is poorly designed, or am I saying that this particular one is broken because I hit it with a hammer? It's just useful to talk in terms of types and tokens in this way. It's just useful terminology for differentiating things. So what this is saying is what it is to think is to produce certain instances of particular mental symbols in causal strings one after the other. So let's go with an example. So it's a little clearer. Let's play a fun game. Is this box gonna fit in this box?
Yes.
Yes. All right. Why do we say it's gonna fit in this box?
Because this is a smaller box, so it's gonna fit into the big box.
Okay. So it looks like what we're doing is we started off with a question. And what I just want to do now is explaining how this thought process works with explaining it in a representational theory of mind. So what would this look like? How are we going to describe this? Well, first off, we start off with this question of, does one fit in the other? And the first step you said is box. Let's call this box 1. I'll write a 1 on it. 1, box 1, and box 2. Box 1 is bigger than box 2. So it looks like box 1 is bigger than box 2. So let's just call this thing, let's just call it circle, okay? This is circle. And here's going to be our head. So if we believe that which one's bigger? This one is bigger than this one. So what might you say if we're describing what's going on in our head in a representational theory of mind? How would we change this drawing if we wanted to represent what is the first step in our coming to believe that this box will fit in this box?
Do we need to identify what box you're talking about when you say one box and the other box?
Yeah, so I've tried to label them. So this one is just what the name, this is going to be named box 1. This is going to be named box 2. So now that we've said this one is bigger than this one, and we've said that like that is a content, that's something that can be true or false. So another thing we need is it looks like, as a matter of fact, smaller things can fit in bigger ones. So that's another thing. Let's call this one triangle. So that, or let's make it, yeah, triangle. So we've got circle is our name for the fact that box 1 is bigger than box 2. And smaller things can fit in bigger ones, just as a matter of fact, is what we're calling triangle. So what would it be to think, or what would it be to believe that box 1 is bigger than box 2? How would we draw that up here on the board using representational theory of mind thoughts? If here's our head.
Is it like a circle, arrow, and then triangle?
You just have a circle in your head. That's what is it to have this belief? Was to have a circle in your head in a believy way, or to use our metaphor from last time, here's your belief box. Imagine that in your head, this is all metaphorical, but the idea is generally, what is it to believe that a box 1 is bigger than box 2? All it is to have the circle in your head. That's what it is to have a belief and to have it in the right way. And then what is it to have the belief that smaller things can fit in bigger things? How would I draw that in?
Oh, arrow, like.
So
like
before we get the arrow, just what would it simply be? Just like,
a triangle.
yeah, just be a triangle in our belief box. So right now, what I just drew a picture of is the human mind when you're having the belief that box 1 is bigger than box 2 and the belief that smaller things can fit in bigger things. So then what would it be to those of you who said that this box would fit in this box? What did you do? Describe what happened. How did you come to the conclusion?
Well, you showed one angle of it, and I realized that box 2 was smaller than it at one angle. Then you showed the other angle, and I was able to really know if it would fit.
Yeah. So, but the way you worked is you took these ones you had already. You took your evidence that box 1 is bigger than box 2 was just something that you got from looking. But once you had that one, and you had the belief that smaller things fit in bigger things, as soon as you put those two together, you came to the conclusion that one will fit inside the other. And now let's do our scientific test. Does it actually fit? See, ta-da, it fits. Good work, everybody. And the way you got there is what? You just had this mental symbol combined with this mental symbol together in an arrow in a causal process caused this other symbol, let's call it square. And what is square? All square is box 1 fits in box 2. That's all that the representational theory of mind is saying. It's saying that what it is to think is to have these symbols in your head, and for those symbols to mean things out in the world, and then for the symbols to interact with each other in certain causal ways. So just what it is to think is just to have the circle symbol and the triangle symbol together cause the square symbol. Does that make sense? It's like almost so straightforward and obvious that, again, you're kind of like, what the hell's the point? Why are we talking about this? But that's what the representational theory of mind is saying, is that you've got these little shapes, and the shapes together are causing other shapes. And that's what it is to think, is just for these symbols to get moved around, and those symbols have certain meanings and interact with each other in certain ways. Now, the other interesting thing, and why this is a little more powerful than I made it seem, because it's not just that beliefs can cause other beliefs, it's rather that beliefs can be caused and affected, like intentions or things like that. So you can imagine in your head, not only is there the belief box, there can also be like the desire box and say the intention box. So an intention is something, if you have the intention to go to the store, you have a reason, or you're going to act on going to the store unless something gets in your way. 1 second, Eddie, and then I'm going to ask your very brilliant question. So first off, the idea would be, what is it? So I just gave an example of what it is to think. Form a new belief on the past beliefs you had. Now imagine instead of this, you had, let's change these around. You just have circle, which is eat a sandwich. So if you have I have the content eat a sandwich, well, you might say that content eat a sandwich is in my desire box. So what is it to have the desire to eat a sandwich? It's to have the content eat a sandwich in your desire box. If I believed I was currently eating a sandwich, I'd have that same content, a different token of it, but the same shape in my belief box. So right now, this is me believing that I'm eating a sandwich and my desiring to eat a sandwich. But let's say that I don't believe I have a sandwich. It's not in there yet, but I want there to be a sandwich in there. Well, if my desire is to get a sandwich, and say I have another belief, the belief the store sells sandwiches, now I might have, we'll call that triangle, to have the belief that the store sells sandwiches is in your belief box, or to think of it in a believy way, the content, the symbol triangle, this just means the store sells sandwiches. Well, I have a desire to get a sandwich, and I have the belief that the store sells sandwiches. What intention might I form in this case? What might I intend to do if I desire a sandwich and I believe that the store sells sandwiches?
Go to the store and get a sandwich.
Yeah, you intend the content, go to store. And that just enters your intention box. So what is it to come to form that intention was have this particular content here and this content here together cause this content here. So that's what it is to have a thought on the representational theory of mind. It's to have these symbols causally interact with each other. Now, Eddie's question is, couldn't a limited materialist argue that this is too abstract or too basic? And the short answer is yes. And one of the things that materialists argue is we're talking about boxes, we're talking about thoughts. Like what's in my head is not a triangle. Like if you open up my head, you're gonna find a big pile of pink meat. You're not gonna find triangles and things like that. So the question is, how on earth is this a theory of mind if I'm talking in terms of boxes? And what the representational theory of mind says in response to this is that, all right, you're right, it's very abstract, but we have to think about it in terms of these are almost like programs running on a hardware system. So what you can think of these is, yes, they're abstract, but when you're talking about the mind, we have to think of the mind as the sort of thing that is running programs and running things like this. And so, yes, speaking in terms of triangles, squares, circles, blah, 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 is kind of a very abstract way of describing how the mind works. But the eliminative material, or the representational theory of mind response is, we need to be able to give a theory of how thinking works. And we don't have anything other than this sort of way. All we have right now is talking in terms of the mind and mental contents and things causing each other. And yes, we're going to have a lot of questions. And yes, this is very abstract, but it's the best we have right now. And that's what Fodor's stuff in the previous classes were. It was him saying representational theory of mind is the best way of implementing our common sense folk psychology. And if you do that, this is what you end up committed to, this idea that you have symbols in the head that mean other things. And all it is to think is to have these symbols causally interact with each other. So does everyone understand what this basic picture is? It's just, think about the mind almost like a flow chart, and that's how the mind works. It's just a matter of things that mean other things causally interacting with each other. And again, it's the degree to which this theory almost sounds like it's like a weird combination of common sense and like weird metaphors. And so it's worth taking a step back and talking about why it's so profound and why it's so interesting, even though it's some weird combination of common sense and weird metaphors and pictures. But I just want to make sure that the two main parts are, one, what it is to believe something is to have a mental symbol in your head that plays a certain role in your processes of thought, or a certain role in your behaviors. And all it is to think is for those symbols to have causal interactions on each other. That's the basic background picture of the representational theory of mind. And this, as some of you talked about last time, this is a lot like thinking the human mind works like a computer. And that's right, and I'm going to embrace that in a second, but I just want to make sure we're all kind of on board with this picture and how the mind is working. All right. So Alan asks, when we do this kind of thinking, do all these thoughts have to be conscious thoughts? Because for him, at least, he wouldn't think that a store sells sandwich. He'd directly go to the conclusion, go to the store. And this is a really good question of, do these have to be conscious? And one thing that's worth highlighting about the representational theory of mind is it is not taking a stand on this yet. Is this a conscious train of thought? Maybe, maybe not. And so what the representational theory of mind is doing is just giving a general framework to try to understand. And then Alan's question of, does this have to be conscious? Think about what an eliminative materialist, how would an eliminative materialist even ask a question about conscious versus unconscious thought? Doesn't seem like it's even very clear what you'd be asking, but it seems like that's a question we'd want to ask. And a representational theory of mind theorist could say, Alan's question, do these thoughts have to be conscious, or do these thoughts even have to be, can they be unconscious? This is a question that someone who believes the representational theory of mind can ask. They can literally ask questions like, do these transitions have to be conscious? Can they be unconscious? What sorts of transitions are acceptable? So already by asking this sort of question, you kind of, to ask this wonderful question, you have to kind of already be playing the representational theory of mind game. And so this is why the representational theory of mind is useful. It gives us a way of asking these questions. And in answer to your question, Alan, I don't know the answer, and it's an empirical psychological question and the way you'd answer it, well, if we wanted to know, do these thoughts have to be conscious? Does this reasoning have to be conscious? Well, you could run an experiment. You could get people to consciously think through the consequences and compare it to somebody who's not consequent. I'm not an experimental psychologist, so I couldn't design this very well, but that's the way you'd go about thinking. You'd start to define things and look for behavioral differences. What would the behavioral difference look like between the person who's doing the unconscious versus the conscious thinking? And so that's the way in which this can lay at the core of like a large research program. All right, so back, any other questions, comments, concerns at this point? Are we doing all right? Hopefully this is making some, this stuff is both so complex and so simple at the same time. It's very tough for me to judge how well we're doing with it, especially because I can't see confused faces. So Cynthia brings up a great point, which is some of the evidence that people give that it doesn't have to be conscious. It seems like the reason that like a smell of cookies can take you back to your grandmother is it seems like there's something unconscious going on here. So that would be a case in which like maybe this is unconscious, or you might say, well, maybe we need a different sort of transitional approach. Maybe instead of thinking in terms of these like, if this, then this, maybe we think about it in terms of associations or something along those lines. And that's something that'll make a little more sense in a couple of weeks, but that's the general background. All right, so why is this theory, despite its simpleness and despite its weird metaphorical nature, why do we do it? Well, here's the simple answer. How many of you believe in magic? And I don't mean magic like in the you can play, like you can like trick people on a stage. I mean like the genuine sort of like Harry Potter style magic. So how many of you, flipping it around, raise your hand or your thumb if you do not believe in magic? Like Harry Potter style, full on magic. I do not believe in magic. All right, so yeah, most people do not believe in magic. So if there's no magic, anything that happens needs an explanation. You can't just say magic did it. You instead need some explanation for how it happens. And what's one thing in our world that we need to explain? And it's something that is about as close to magic as you can get. So right now, I just engaged in something that's about as close to magic as you can possibly get. So one thing which magicians can do. So let's talk about wizards for a second. And I mean like wizards. So tell me some things about wizards and what they do. They wear hats. They have big beards usually. What are some of the incredible powers that wizards have? What can a wizard do? Gandalf, Harry Potter. What are some of the things they can do? They can turn you into a sheep. That's one thing. What are some other things they do? They can become invisible. Let's think about a particular one. Fly with a broom. That's another good one. But here's one. Harry Potter's on one side of the room, and across the room, there is something else that he wants. What can he do? Yeah, he can teleport it to him or lift it up and carry it. Now, here's a fun fact. I just did the exact same thing, only at a distance way farther than across a room. What was my magic trick? What wizard behavior did I just engage in? I just did something way more. Yeah, Cynthia is correct. I got you all to lift your hands or press a button from halfway. Like, fact of the matter, I am not in New York City right now. I am hundreds of miles away from you all. And yet I got you all to move your arms. That's not Harry Potter lifting up something from across the room. That's way better. That's through a camera, through a digital line. I controlled your behavior and I affected the world from over 100 miles away. That's magic. That's about as close to magic in the real world as you can get. And yet we also all said we don't believe in magic. So we need an explanation for how this is possible. And we need an explanation for how this is possible that's not done in terms of wizards, but in terms of meat and behaviors. I need to explain how that's possible in terms of the big piece of wrinkly grayish pink meat in my head and the big pieces of wrinkly pinkish gray meat in your head. Yeah, now there's something, when you pause and think about it, magic, like human communication and interaction is about as magical as anything a wizard does. Like, yes, I cannot turn you into a sheep, but I can get you to behave like a sheep. Like if I told you all, like, I'm gonna fail you unless you shut off or turn on your microphones and start going ba, 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 good number of you will probably turn on your microphones and start going ba, 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 ba. So this is a case in which human beings, we don't believe in magic, and yet we look around at our own behaviors and it's about as close to magic as you get. And we want an explanation for this that doesn't involve saying, well, thinking is magic. And what the representational theory of mind does is it gives the outlines for how you can explain thought and how you can explain meaning and how you can explain interactions between really dumb pieces of meat and the external world and this incredible behavior without having to point to magic. And that's really why the representational theory of mind is so powerful, is you are all generally able to understand the very basics of what I was talking about with this symbol causing this symbol causing this symbol. And it was described in very simple, basic, almost some combination of common sense and metaphor terms. And yet the idea is this simple system is going to be able to explain something as magical as the fact that I get you all to do things I want you to do from 100 miles away. And the way it does that is in terms of speaking in terms of symbols and manipulations of symbols. And the basic idea is we can explain something incredibly complex and incredibly smart in terms of something that's much dumber. And that's really what science is about, is explaining really complex things in dumber, simple terms that you can give a mechanical explanation of. And the reason the representational theory of mind is so powerful is it shows a way in which you can explain complex, smart thought in terms of dumbness. So does everyone understand like what the background is? And now I'm going to show a little bit more about why, for the representational theory of mind to work, it produces smart things. But the system itself can be quite dumb and mechanical and give like a very straightforward, simplistic explanation for how smartness comes about if you accept certain basic premises. And that's why, or certain background conditions. And that's why the representational theory of mind is so powerful and great. Do you understand the magic point though? Like if you really want to just think about things that you take for granted every day, and like it's really spectacular how complicated and like the tasks you take for granted and think are very simple or easy are incredibly complicated, and when you break them down are so difficult. So for like just another side thing, how many of you in your head find it very easy to do complex multiplication? I find it incredibly difficult. I forget most of my math. You know who's really, really good at it? A computer's good at it. But they've not yet really been able to figure out how to make computers like robots walk all that well. Like walking is an incredibly difficult task, and robots are getting better and better at it, but you still can't get a robot. Like you can get it to use wheels pretty well, but in terms of like 2 legs, it's very difficult to design a robot that can move as naturally as a human being on 2 legs. And in the same way, well, walking is something we take for granted. It's actually quite a complex task. So how is it that these complex tasks are carried out? Well, it's just a matter of computation or representational theory of mind stuff. All right, my head just got fuzzy, so I'm gonna take a sip. Think if you have any questions at this point about any of this stuff. And now what I'm gonna do is talk about the computer metaphor and why it's so powerful and useful. All right, is anyone here a computer programmer? Anybody? Anyone generally understand how programming languages work though? Okay, K1 does Python. I'm not an expert on it, so Alan took a couple classes in high school, but basically, so I'm not a computer programming expert by any means. So I'm just gonna explain things in very, very simple terms. But when you're designing a computer program, all you're doing is writing lines of code in a particular programming language, where basically all you're doing is coming up with strings of symbols. So computers do really complicated things, but computers themselves are not actually aware or smart. They don't have like impulses. It's rather they just do simple symbol manipulation. So for instance, if you're in a certain let's use our simple programming language, you might have a programming language in which you just write a rule. So the way to think of it is programming languages are just rules and symbols about how to manipulate the rules. So here's a simple rule. Rule 1. If you have a circle, turn it into a triangle. If you have a triangle, turn it into a square. This is like a very simple rule that's just about symbol manipulation. So if you've got a circle and you turn it into a triangle, now imagine I tell you this. You are going to be my dumb computers. Step 1, I give you this. What do you do next? I say, now run the program. The program's defined by these 2 rules. What do you do to run the program? Run this program on this. What happens now? What do you do? Yeah, triangle. Those of you who are saying triangle, to run the program is just you get triangle. And then what's the next step? What's going to happen next once you've run triangle? Once you run rule 1 to get a triangle, what happens now? You get a square. That's about as simple and dumb of an operation as possible. So all you do is say, you have a set of rules. Rules in a computer would say turn circle into triangle and then turn triangle into square. And if you run, this is all the program is this set of rules. And then the input to the program is circle. You just give it circle. And at the end, you end up with square. That's the simplest way of understanding computer programming. Now, of course, computers are so powerful because they involve a lot more than 3 symbols and yada, yada, yada. But that's all the basic idea of running a computer program is. The idea then of the representational theory of mind is, and this is the computer metaphor that Fodor talks about, is just, this is exactly how you should think of a human mind. It's just a series of these rules and symbols that go in the rules. So what is it to think this box will fit in that box? Well, it's just to, or here's a better one. Which of these are bigger? You already said this is bigger than this. Now, which of these 2 are bigger? Marker or box? Yeah, box is bigger. So therefore, I'm going to show you something, and then you're going to run the rule, is it bigger than? So box and this box, you output, this one is bigger. No, we'll do it this way. Which one's bigger of these 2? Well, you say this one's bigger. That's rule 1. We now have this box. I now ask, this box or this box? You output this box. That's all it is to think in terms of symbols. And the key is here that you think of the symbols. All the system has to do is know these rules. It doesn't have to be smart. It doesn't have to know what they mean. But here's where the power of the thinking is. You also say, you give meanings to the symbols. You say that each symbol corresponds to something out in the world. So just to take a, let's go with an actual one. Here's a rule that most computer programs will run and which you should be able to run. And the way these rules are just written in terms of like variables and rules. So here's one rule. If X, then Y. That's your rule. If X, then Y. So now imagine that if this is your one rule, I input X into the system. I give your mental system or this computer an X. What gets spit out?
Y.
Y. Now here's where the genius comes in. Imagine if instead of just having these referring to things, imagine that they're blank spaces. Or you can think of them as literally a Tetris shape. So if something is shaped like this, then output something else shaped like this. So if I give you one of these, what's the output going to be?
The size of the L.
Yeah, it's going to be the L-shaped one. Now, what if I were to give you this? This is the starting one. What would happen? If this is the input, no output. Yeah, the system shuts down. So the way you can think about how a computer or the mind would work would be there are rules installed in the mind that tell you which symbols can be turned into which other symbols. So in this case, we could say that this is a good rule, or what the mind is, the way the mind thinks is this is a rule of thinking. If you have this, then you have that. So in this particular case, if you have this and then that, and you then input this into the system, that Tetris piece goes in, output comes this Tetris piece. That's what it is to follow a rule of thinking. This is just what it is to think according to this. The key comes in that it's not just that this is a shape. What does this also do? It has a meaning. It is a symbol for something else. So there's also built into the system something which gives each symbol meaning. And this is where, so it's not just that this means blank, it's that this say anything that is this shape is the shape, this means animal. So if it's an animal, then what's something that's true of all animals? I don't know. Yeah, it's alive. And then we could say equals living thing. So a system, anytime you give it anything with this shape, any animal is going to be this shape. So in this symbol is just going to be defined as all the, so you could think of this shape number 1 would be dog. This shape number 2 would be cat. And then this just means living thing. So what a system would be able to do is anytime something with this shape goes in there, it's going to output this shape. But, so this is a very dumb process. But the moment you say that these things are symbols for other things, what this system is able to do is tell you which things are alive and which things are dead. So it can tell you, is it a cat? Well, a cat is this shape. It'll fit in. It'll output alive. What if I give you something like this? This is a symbol for equals chair. What would happen if we do the test? What happens if we're asking the question, are chairs alive? Well, all it is to think the question, is a chair alive, is to try to put this symbol into this formula. What happens if we put the chair symbol into this formula? Yeah, 404. Yeah, the system's going to break down. It's not going to work. So, background. This got a little boring and involves a bunch of shapes and symbols. And if you're not a computer person who finds computer programming interesting, this can get very boring. But the basic idea behind this is, here's a complex thing that we think only a human being could ever carry out. Is some particular type of thing alive? Well, is a cat alive? Well, I ask you, you have to think about, is a cat alive? Well, is a cat an animal? Blah, blah, blah. But you can get a dumb system to come to the correct answer if you define the processes in terms of symbols, and you say that these symbols are things with meanings that represent other things. Yeah, so here's the thing is, what Ray just pointed out is there's a difference between the computer and the mind is the computer doesn't know that one box is bigger than another box. Like a computer doesn't know that the reason that this shape leads to this shape is because for us, we'd immediately know it's cat, therefore animal. A computer doesn't know that. all a computer, Nafis, you're asking the perfect question, which is exactly what I wanted to ask next, which is, okay, so if this symbol gets turned into this symbol, the computer doesn't need to know what these mean. All it needs to do is know how to do the symbol manipulation. And a computer cannot, on top of that, ask questions. And it seems like a human being can ask questions on top of it. It can somehow know what these meanings are. And so there is this big question of how do we know what the symbols go with which meanings? And also, what do we know the rules are? But the general idea of how thinking can be described mechanically seems to be explained on this set of rules. All thinking is stupid symbol manipulation plus whatever level of human awareness we have that makes us special, and where that comes from, etc. So according to RTM, the question then becomes, so does everyone understand what, like, I'm sorry that the symbol manipulation stuff gets a little boring, but, and I know it's finals or midterm week, so this is not the most exciting topic to hold your attention during midterm week. But do people understand generally, before I answer the question about where these rules come from, etc., do people understand the general background of what's going on here, how it works, and why representational theory of mind is supposed to be so powerful? It's supposed to show you how you can get a dumb system to do smart stuff, and it seems like the only account we have of how dumb systems do smart stuff.
Yes.
Okay, just making sure. I'm just making sure there's nobody who's going to say no. All right, I'm going to erase this, and then I'm going to jump into the questions that arise, one of which is, how do we use RTM to explain those things that just pop out of a mind from nowhere? So here's one of the things that representational theory of mind, just as a matter of fact, the representational theory of mind, most people today believe there's a lot of unconscious processing that goes on. So the way they would explain things that pop into your head from nowhere is your conscious mind is not aware of most of the processing that's going on in it. You can think of the human brain as most, and this is part of the motivation for the RTM, is that it seems like many of the things we do in our lives, we reach conclusions in incredibly complex ways that we need some explanation for. And so what they'll say is that most of how human processing works, most of it is at an unconscious level. And so when you think something just popped into your mind, it's not magic. It can't be magic. There has to be some explanation. And what's the explanation? That you're running tons of unconscious processes. And these sorts of things are used to explain a lot of behaviors. And so the reason is, how can we do these smart things without unconscious awareness or without conscious awareness? Well, the smart things are being run on programs under the conscious level. So in the same way, like our computer, it's running programs in the background that are keeping the, the computer from overheating and every other thing. Well, your mind is also running those. You're just not paying attention to those ones. Your attention is focused on whatever your attention's focused on. And the things that just pop into your head are the things that are happening in the background or under conscious awareness. All right. So where do these come from, though? What sorts of, where do these rules come from? The idea is, we're saying representational theory of mind says to think is just to follow certain rules. Well, then where the hell do the rules come from? Well, what most representational theory of mind people think is, well, some of the rules are going to be learned over the course of your life. When you learn a new style of thinking or a new problem, you're adding new rules. But of course, you can't just, what's the thing about learning? Whenever you learn something new, think about Algebra 1. No, let's go with algebra pre-calculus. No, let's go with calculus. How many of you took calculus? I took it and I forget every second of it, but I know I took it. What class did you take before calculus?
Pre-calc.
Pre-calc. Why did you have to take pre-calc?
It's a prereq for calc.
But like, so in practice, it's a prerequisite, but why do they make it a prerequisite? What is the reasoning behind it? Prerequisite, yeah, it's a foundation. You can't understand calculus without understanding pre-calculus. And what do you have to take before pre-calculus? If I remember my math correctly, yeah, you have to take some sort of algebra. And before you do algebra, what do you have to take? Yeah, you have to take trigonometry as well somewhere in there.
I think like first is algebra, geometry, trigonometry, then pre-calc, then calc.
Yeah, that sounds right. But even before algebra, why were you able to take algebra? What was your prerequisite for algebra?
8th grade math.
Yeah, 8th grade. You had to be able to, yeah. Ray's right. You had to be able to count before you could do it. So everyone see that like each level of the thinking comes from something else. So what's an obvious question at this point? So let's say, how do you learn math? Well, how do you learn calculus? You first learn pre-calc, yada, yada, yada. What's a question that's going to come up at this point? How do we know 1 + 1 = 2? This is Ray's question of where's the first step? And this is the real issue with this sort of representational theory of mind. And the answer to how do you know 1 + 1 = 2, or to go with an actual case, is if something is gloop, then it's loop. No, then it's schloop. I'm gloop. What can you conclude from this? If something is gloop, then it's a schloop. It is a schloop. And I'm gloop. What do you know? I'm a schloop. Whatever a schloop is, I'm a schloop. How did you know this? Well, you follow this rule of modus ponens. So what's the answer to where does this rule come from? It seems like you need something built in at the beginning. And so what the representational theory of mind people generally say is there are certain rules that are pre-programmed into the system in virtue of being a human being. So one of the keys with a representational theory of mind is this background assumption that we are not born as blank slates. We have stuff pre-programmed into us. So why is it that we accept this rule, modus ponens? Well, because modus ponens is one of the rules that is pre-programmed into your head. Kaywin, yes, very Kant. It's very Kant or Cartesian. It's this idea that the human mind is not a blank slate. And Ray says it's just obvious to us. And the reason it's just obvious to us is because it's hardwired in there. Now, that's a very strong claim. Why think that it's hardwired in there? Well, the reason to think that these rules are hardwired in here is, well, why would modus ponens, the idea that if A, then B, if that's premise 1, and you have premise 2 of A, conclusion B, why would that be something? Why is it reasonable to say this is programmed into your head? Did it just get blurry on me again? Or are we okay? Okay. We are okay. All right. All right. Why would you think this is programmed in your head? Where would it come from? What is the reason to think this is the case? Anyone have any ideas? What would be the main explanation? All right. What is a human being? I'm going to break this. So one is it works. That's one thing. And if it works, why would something that works end up be programmed in? How did it get there? What are human beings? Yeah, evolution. This would be the explanation for why we follow these rules and how they got in here is evolutionary. So another thing about the representational theory of mind is it combines certain sorts of elements of how the human mind works with certain evolutionary assumptions. So here's an actual case. You've got two organisms, one of which has a rule in its head. Here's its head, and in its head, it's got modus ponens. So anytime it believes if A, then B, and it sees A, it automatically concludes B. And you have another organism that doesn't have that in there. So imagine, here's the case. There's a particular berry that always grows right after it rains. Whenever it rains, that thing grows. And it's a very good source of food back in our ancient caveman times. So it's now raining. What can the organism that has this rule built into its head do? It sees it's raining. What can this organism do? And why can it do it? So again, here's the idea. Here's a fact, whenever it rains, the healthy berry grows. So what can this organism that has modus ponens, can think in this way, do that this organism cannot? If it sees it raining, what's it going to know to do? Yeah, it's going to, thank you, right. It's going to know the berry is there and it's going to go gather it. How many of you have worked with parameciums in like high school biology class? Anyone remember those little tiny like things with the microscope? Did anyone do this? You looked at like amoebas through a microscope. Has anyone seen anyone else look at amoebas through a microscope? Like, do you understand the general idea? They're like single-celled organisms. They look like this and you can only see them through a microscope. Does anyone know how they decide where to go? Like if you drop food, like imagine here's a paramecium. Here's food over here and there's food over here. Which one is the paramecium going to go to? Or no, there's food over here and no food over here. Which way is the paramecium very often going to go? It's totally random. The paramecium generally cannot detect it. All that ends up happening is it just ends up getting lucky and it just goes around in random shapes until it eventually lucks upon food. Why? A paramecium doesn't know. It doesn't have cognitive capacity. It can't reason this out. A human, however, so this organism that has modus ponens, has these rules built into its system, will automatically know where, like, can draw conclusions that this one cannot. So if you didn't have this thing that seems so common sense to us built into our system, then if it rained, the organism that can't draw this conclusion isn't going to know to look for the berries. The organism that does have it is going to know to look for the berries. Therefore, this one's going to get a head start. It's going to get the berry. It's going to have more children. And this is how the human mind can be shaped by evolution in the same way that like a giraffe's neck is. Why is a giraffe's neck so long? Let's go through our basic old biology stuff. What is the reason the giraffe's neck is so long? Who was paying attention to biology class? Give me the 101 of how evolution works. How does it work? Give me the mechanism. It is evolution, but what is natural selection? This is just a fun like little side note on who remembers their biology.
Essentially, the features that are, viable to survive will go on and to survive through mutation, everything. Those that are undesirable will thin out.
Yeah, so basically we think of it, yeah, so Kaywin's right. So basically here's, those who are buff get the girls. So basically one way of thinking about it is it's not that the giraffes saw the tall fruit and extended their necks. It's rather that all the giraffes that had, like each generation, you have two giraffes. Giraffe A, which had a neck that was this long, and Giraffe B, which had a neck which was this long. They're not that different, but Giraffe B's is just a little longer, which means this guy can reach a few more fruit. That means over time, the ones with a long neck are going to get more fruit, have more babies, and survive. This one's going to die off, and each generation it gets longer. So in the same way, the human mind over time will start to develop these logical rules that are built into it, which govern how we think. So the idea about with the representational theory of mind, you can think of it in this sort of way. We have, just to summarize, there are rules of thinking programmed in. 2, symbols that stand for things. 3, so you've got the rules of thinking, symbols that stand for things, and then thinking is just applying those rules to those symbols. That's all thinking is on the representational theory of mind. So Alan asks, do other animals exhibit this thinking structure? And if they do, why are humans different? So here's some fascinating things about animals. is it seems like there are a lot of basic behavioral things that certain animals follow and others that they don't. And a question that you might have is like, what logical rules do animals have? And it seems like, as a matter of fact, the higher up the like evolutionary chain, or I guess more accurately, the closer to us you get, the more rules that you have that are similar to our own. And it seems like one of the differences is that we just have some additional, more complex rules on top. So for instance, there's a lot of evidence that very low-level animals are able to design very complex mental maps of how the world is laid out. So if you, back in like behaviorist times, they used to think that how is it that a rat knows how to get through a maze? Well, the rat has to do it, the whole maze, and then it learns it. But one thing about rats is they can watch other, they can do the maze, or let's go with octopuses. Octopuses can learn by observation. If you give an octopus a screw top jar, octopus can't get the lid off. If you take the jar, unscrew it, screw it back on, and give it to the octopus, it will immediately unscrew that. So it needed to think in terms of like systems, like that is the act of unscrewing the lid. That organism can unscrew the lid. I too am an organism. I too can unscrew that lid. So certain other organisms do engage in this sort of reasoning, and sometimes quite complex reasoning, just they do different reasoning and not all the sorts of things we do. So it becomes a matter of degree, not a matter of kind. So that's another thing about the representational theory of minds, is it's starting to think of us as just like other organisms, just a bit more complicated, and we result from the exact same processes, evolutionary and otherwise, that cause these other organisms to behave how they behave. It's just we're a more complicated organism. So according to representational theory of mind, all that stuff about Fodor, all that background is basically just to say that all it is to think is to have a computer in your head running programs over symbols. These symbols mean things in the world. They represent things. This is responsible for the content, these symbols, and then these rules explain why we're able to come and think. And all you're doing is just symbol manipulation. And so this, at the end of the day, is what it is to think. All thinking is to run a computer program in your head. That's the core idea. And another way of thinking about it is this is a computational theory of mind. And in the same way that you can begin to understand once you know a computer's computational, you can begin to design new programs and begin to understand which programs are there. That is the basic idea of why, according to this, psychology is possible. What it is to ask questions like how do we think is to ask what programs do we run? What rules do we follow? What are these symbols like? How is it that they interact? And so to take an example like, you've got somebody who's got really negative, depressed thoughts about themselves. They hate themselves. If you begin to understand, you might ask, well, where did that thought come from? Or how can we get rid of that thought? How can we get it to stop? Well, you have to understand why that conclusion was reached, how that symbol got in there, and then how could you get that symbol out? Well, certain rules of thinking might work better than others. Which rules do we follow are going to be crucial steps in understanding how we can get this person to behave differently. All right, we are out of time. Did this make sense? Like, did this overall general picture of basically the background here is if we think that the mind is the computer, we can have ways and questions we can ask that are open to, it's kind of like this is the entire background of an entire field. Let's assume the mind is a computer. And once we assume that, what else can follow from it? So I'm going to talk in the lecture about the language of thought, which is going to be the bonus lecture, which is going to be an explanation what the language of thought is it talks a little bit more about what these symbols are like. And what I want to talk about in the next few weeks is to think, what are the symbols in our head like? Because once you understand what the symbols are like, you can understand what sorts of programs can be run. And so these are really the two questions we're going to be looking at in the next couple of weeks with the language of thought and then dual system theory, which is just looking at how do the how do questions about what the symbols are like affect more of our understanding of how thinking works? All right, I'm gonna stop here. Hopefully that wasn't too bad. And I will see everyone next week, and I will post that